Okay, here's example, actually it's not example 4, it's example 3. Example 3 for the trig integrals here. So here we have the integral of sine to the 4th power. Last time we did the sine to the 3rd power. If you think about it for a little bit, you'll start to realize that the strategy that we used last time doesn't really work anymore. Because if I try to use this identity, I'll have to break off a sine squared, which leaves me with another sine squared. And then if I try to change this into 1 minus cosine squared, I really have no way of doing u equals cosine. Because u equals cosine will get rid of one of the sine x from the derivative, but I still have another one here that's causing me trouble. So this probably isn't the way to go. Now these last two identities are probably going to be what's useful. So we're actually going to do that. I have a sine squared here, so I'm going to write this in terms of sine squared. Sine squared squared, multiply the powers, that gives me sine to the 4th. Now I'm going to replace this. I have sine squared x. I'm going to replace that inside with the trig identity. 1/2 times 1 minus cosine of 2x. Sorry, I'm writing in blue. Gotta square it. So now let me actually square it. I'm going to FOIL. 1/2 squared is 1/4. I'll leave it outside. And I get, I'm going to do FOIL on this. 1 minus 2 cosine 2x plus cosine squared of 2x. Now, at least these two integrals are easy now. I get 1/4, and I have x minus the integral of negative cosine is negative sine. So I get minus 2 sine 2x. But because of this 2x, I got to multiply by 1/2. That's part of this linear u sub thing. But then I have to worry about this. So I'm actually going to leave this parentheses out. I'm going to do 1/4 rewrite. I still have to do this integral. So this still looks pretty bad and I'm not sure what to do with it, but at least I've gotten from a 4th power to a 2nd power. What does that tell me? I probably need to use one of these again. Now I'm going to use the bottom one. And this is going to be really, really tricky. So if it slips by you, rewind. Cosine squared of 2x. I have cosine squared x here. I'm going to write in green, I'm going to rewrite the identity with 2x instead of x. Because I have cosine squared of 2x. That's going to be 1/2 times. The x I'm going to replace with 2x. Cosine of 2, I got to replace the x with 2x. So I actually get a cosine of 4x. 1 plus cosine 4x. So that's really, really, really hard to miss. But now I can sub it into my integral. I have x over 4 minus 2 times 1/2 cancels. I get 1/4 out front. Sine 2x. Please make sure you're keeping track of your minus signs. And then I have plus 1/4 integral, and I'm going to rewrite this. 1/2 times 1 plus cosine 4x dx. Now, things still look really gross, but at least I can integrate now. X over 4 minus 1/4 sine 2x. Oops. I have 1/4 times 1/2 is an 1/8. And then I integrate. I'm going to do it without writing. I'm going to integrate this thing in green. because I've taken care of these two constants. Integral of 1, got to keep my parentheses, is x. Integral of positive cosine is positive sine. But because I have 4x, I got to divide out here. And here we go. That's it. It's x over 4 minus a quarter sine 2x plus x over 8 plus 1 over 32 sine of 4x plus c. And I guess if you wanted to, you can combine these. A quarter x plus an eighth x will be 3/8 x. And there's your answer. Was kind of disgusting, but at the very least, this is just what makes this section tricky. This integral looked so similar to one where I just replaced the power by 1. Sine cubed x versus sine to the fourth. You have to be able to tell in advance which identity is going to work first. It was not the Pythagorean ones. Not only which identity to use, but how to actually see how to use it. And then obviously being able to do the algebra. It's a tricky problem, but stick to your guns and you'll get it.